Welcome everybody, thanks for turning up in such nice numbers. My name is Laurent. I just started to work at Gradle yesterday, so I might not be the right person to ask about really deep internals, but I already worked with Des, who's I don't know where, on dependency substitution while I was working at Prezi. I don't know if you've seen my talk last year, maybe some people have. So we would like to walk you through this new feature in Gradle 2.5. And I'm going to talk a little about why we have this feature and what you could use it, a couple of use cases. And Des is going to dive into the specifics, like what the syntax looks like and what we had to do to get this to work. And there was quite a bit of refactoring in the dependency resolution mechanisms and task graph and stuff like that. So it's going to be interesting, I hope. This is about large modular applications mostly. So for the question of dependency substitution to come up, you need a large modular application mostly because, well, that's when you have lots of dependencies that you can replace with each other. So as far as I know, there's two approaches to a large modular application. Either you have all your eggs in one basket and put all your stuff into a large multi-module Gradle build in one repository, or you have lots of small repositories, or well, the repositories don't really matter, but you have separate builds, separate CI builds that build each component and publish it perhaps to Artifactory or Nexus or whatever you're using. In both cases, it comes up the same problem of how your developers are working with this big application, how they can focus on just a few modules that they really want to work with, and how the workflow works. So I'd like to focus first on the separately built components approach, because that's what we had in Prezi, and that's what drove this new feature. So so you have a large application with many modules, and your dependencies are basically declared as external dependencies on some artifact in Artifactory or something. And when developer works with this application, this product, they actually most of the time don't want to change everything at once, right? They just want to focus on a couple of stuff. They want to have those things as local sources on their computers, and they want to work with those sources. They want to make changes, they want to test it. Of course, they want quick feedback, and while Gradle is doing a great job at incremental builds, the first build they have to do is usually quite long, so that they have to rebuild everything. And sometimes you even need to install tools to build like a module like C there, which you're not going to change, but you still need to install, I don't know, Haskell or some exotic stuff that is going to slow you down. And setting up new workspaces, setting up a new environment where you can work on a new feature is, I think it's vital, because sometimes you want to work on more than one feature, sometimes you want to fix a bug very quickly, and you need to just pull up a new environment. So I think the time to get to the first build is really important. So so basically the question comes up that why do you want to actually build modules that you're not touching when they're already built and tested and everything, and they are deployed to Nexus or Artifactory? So that was the use case to develop Pride at Prezi. Who has heard about it? Anybody? Okay, some people, good. So what this tool does is that you have a directory, you clone a couple of modules, and what it does is it pulls a virtual project on top of this. So each of the modules themselves have a standalone Gradle build, but you can just put another build Gradle on top of it, in the settings Gradle, and it works as a virtual super project, and then Gradle knows about all your projects. So now you can actually have project references, project dependencies between the projects that you care about, and have external dependencies on artifacts that you don't want to change in this session. And this works pretty okay, but you need some, so the approach works, but you need some kind of way to tell Gradle that which dependency is going to be a project dependency, which dependency is going to be an external one. There was no built-in feature for this before, so we named this project nesting, that you can nest projects underneath other projects. So what Pride does, and I heard that quite a few people do something similar, that Pride introduces a new extension, but you can also just introduce a method that injects the right dependency. So lots of people have tried this to work around this limitation that you have to decide up front whether this is an external or project dependency. So Pride does this, and when it notices that it has the local sources for a project, it's going to just create a regular dependency in the dependencies block, like project dependency, and if you cannot find the right dependency, it's just going to create an external block. So this sort of works. There's a downside that you have to introduce a special non-standard DSL, which you have to explain to your developers, and there's no online documentation. It's always troublesome to deviate from the standards. But there's another problem. So if you want to set up something like this, so you want to work on A and F here, right? The problem is that to process this dynamic dependencies block, it has to be in one of the built Gradles. But the C and the D modules are just going to be downloaded as jar files or whatevers, and there's not going to be anything for Gradle to process. So in reality, A is going to depend on the external version of F, and that leads to really hard to debug problems. The naive approach leads to certain problems. So this was the reason why we worked with Des quite a lot on introducing dependency substitution. So what you can do with it is that you just declare your dependencies in the usual way, and you declare some rules how the substitution should happen, or what dependency should trigger it, and what it should be replaced with. Des is going to talk about the actual syntax, so I didn't put anything about that on the slide. And then you end up with actually running with project dependencies. And of course, the same thing works the other way around. So the new thing here, so Gradle already had ways to substitute some dependencies. So like conflict resolution is one way to replace one dependency with another, forcing version number as well. The new thing here is that you can do this with any kind of dependency, and it complicates things quite a bit. But on the surface, on the user side, this is just going to be as simple as declaring that, hey, this dependency should be replaced with that, and that's the whole story. So this is about the approach when you have separately built modules. What happens when you have just this one big multi-project that you want to build, and of course your developer is going to modify some of these modules, but not all of them. Again, why do you need to build those parts that are already built by CI and tested and everything, and why spend time on that? So what you can do, of course, is here in this case, you have project dependencies. What could be, again, with a clever rule, there's no already existing solution like Pride for this approach, but it should be pretty simple to implement, I guess, to detect that, hey, module C has no changes, so why don't we just pull in the already built jar file instead of that. Yeah, so that's about it. What did I forget? Yeah, so we also want to work a little more on this. So you've seen the project nesting thing. It's not really perfect at this point because, well, you have things like there's like the root project property that you can now use. If you nest your projects, it's going to be a different thing. referencing one project from another is also a problem right now because, well, it uses an absolute path approach, and if you're nesting your projects, it's not going to work. So we plan to fix that, and the settings Gradle is hopefully, I'm looking at you, is going away, right? Eventually with the new configuration model, so things are going to be simpler to do this dynamic nesting if you want, and build up virtual or even non-virtual projects from standalone Gradle builds that can work in a fluid way. So if you have this thing, we have also another feature coming up which is going to make this obsolete already, which is the distributed cache, which Hans was talking about. So instead of a project level caching of artifacts, that's going to cache the output of separate tasks, and it's going to, so if the task is already ran with the same inputs, you're not going to have to run it yourself. But that's targeted for Q3, 4 this year. So until then, at least, I think this is going to be helpful for some large projects to bring the clean build time down a little. So I'm going to give it over to Des now to talk about how. Shall we do the questions now or at the end? Let's do it at the end.
Okay.
Okay, so so I give it over to Des to talk about the syntax and the implementation details of this feature. Thank you.
So yeah, my name's Daz. I'd like to welcome Laurent. He's joined Gradleware, or Gradle Inc. this morning. I think it's his first day, so he's, thanks very much, Laurent, for the introduction there. I have a funny story. So my name's Daryl DeBoer. I've been a developer at Gradle for about 4 years now. A funny story, everyone calls me Daz, that's my nickname, and when I first met Laurent about a year ago, he was introduced to me and he was sort of staring at my name tag, and it seemed like there was something really strange. He goes, D-A-Z, hang on. He's been looking through the Gradle source code and looking at this place where he sees to-do:-DAZ and something, and he just had no idea what it would mean. What's a DAZ? Why do people have to do this thing? That was me not finishing things, leaving to-dos with my name on in the code. So yeah, it's kind of funny. So yeah, people call me Daz. I've been at Gradle for about probably 5 years now. So my experience is mostly around dependency management in the early days, and I've done a bunch of work on C++ implementation in the last couple of years. So so thanks Laurent for the introduction to the sort of the problem domain of multi-project builds. You know, there's sort of, when you only have a few modules in your project, it's not such a big problem, but we have people who work with 3,600 sub-modules in a single multi-project build, and you can imagine that becomes really, it's not just performance that becomes unmanageable, it's also unmanageable because your IDEs don't work very well when you have that many projects open. You know, you just don't want to have clone that many projects from Git. You just don't want to have that much code on your machine. It just doesn't make sense. But these people are producing a single application out of these 3,600 modules. So it makes sense that they are one build in some ways. So it's interesting, that's the problem domain, and what I'm going to talk about today is a new feature that's coming out in Gradle 2.5 that Laurent mentioned, which is dependency substitution rules. So this is a key ingredient to make your multi-project builds fluent. So, which is when we say fluent, we mean sort of flexible, move things in and out, not have to have the sort of rigid structure of what your multi-project build is. Something coming out in 2.5. The benefits of this is that we're going to support, basically working around a bunch of the problems that Laurent mentioned. No need for a custom DSL to support this sort of interchangeable dependencies, and also the big one, supporting transitive dependency. So be able to replace a transitive dependency with a project dependency. Supporting all types of dependencies, so project dependencies and external dependencies, but also with the new model, the new software model that we're developing, there'll be library dependencies, which will be something different again. That's in the native domain, we have library dependencies. So that's another type of dependency that will be supported out of the box by this feature. First I want to talk about dependency resolve rules. So this is basically the existing implementation of how you do dependency substitution in Gradle. How many people here have used rules like this in the past, each dependencies? So a lot of you have? Okay, cool. So I mean, they're actually pretty cool. They're pretty powerful things. You know, you can basically replace and tweak any of your external dependencies, and you can change the version, you can replace the whole dependency if you like, you can do all sorts of things. So there's some really good use cases of this. An example here is forced versions. Now we do have a shorthand syntax for creating forced versions, but if you want to say for every, but this is actually a bigger force, we're saying every single dependency that's in the org utils group, use version 1.5. An example would be I'm using Spring Framework. I want to always be using exactly the same version of every jar in Spring Framework. So it's a big unit of things. We want to make sure they're all the same version. A couple of other examples is blacklisting a version. So you basically say, if 1.3.1 of this version is of this thing is ever asked for, use 1.3.2 because we know there's a bug in 1.3.1. So you can just blacklist a single version, or you can use forcing like this. So that was dependency resolve rules. These are still around. They'll be around in Gradle 2.5. The intention is to deprecate and replace, and I'll explain why a little bit. So, yeah, so the new feature coming in 2.5 is dependency substitution rules. So the original plan was to just basically enhance the existing functionality, the dependency resolve rules functionality. Basically go, oh cool, this kind of works, let's just make sure we can put project dependencies in there as well and everything will be fine. And there was a couple of complications. One thing is, we weren't able in a backwards compatible way to support the new types of dependencies, like library dependencies that we're bringing out. Because of the API, it was very focused around group name version in the API. There was no ability for us to say, actually, this dependency doesn't have a concept of a group. So because it was baked into the API, it was sort of hard for us to adapt it. So we thought, well, instead of doing that, let's deprecate the old one and replace it with the new one. Another reason we had to do this is there are some interesting complications that come in when you start replacing an external dependency with a project dependency. And I'll get into them a little bit later on. So because of that complication, we wanted to make it a very explicit decision. You can say, I'm now using dependency substitution. I'm relying on my dependencies being fluid. And because my dependencies are fluid, Gradle needs to resolve things in a slightly different way. So there's an opt-in mechanism here, whereas if we just said we're changing the way dependency resolves rules work, suddenly people would get changed behavior with their existing builds, and that's something we work really hard on at Gradle, is not breaking existing builds. Okay, so have a look at the new DSL for dependency substitution. So this is an example of substituting dependencies with basically just doing what you can currently do with dependency resolve rules. We've got I guess more of a Fluent API for this, hopefully making it a little bit simpler for the simple use cases, a bit more readable syntax for this. So once again, we're doing this on the configuration. So I'm looking at a single configuration here. It's the compile configuration, and I'm grabbing the resolution strategy. So the resolution strategy is how do we resolve this configuration? It's not information about the configuration itself, but it's information that feeds into the resolution. So you could resolve the same configuration twice with two different strategies, and in theoretically end up with two different results. And then the actual block that we use to configure our dependency substitution rules is dependency substitution. So the first one here is pretty straightforward. We're saying substitute this module with a different module. So in this case, we haven't specified a version on the module here, which just means any module dependency, any external dependency that's from org, the group org, and with the name util, replace it with org util 1.5, which is the same as the previous example. We're just basically forced. Well, sorry, it's not quite the same because it's only replacing a single group name with a particular version, we're forcing the version. And in this case, we're blacklisting a version where we're saying org util 1.3, we want to blacklist that. Should never ever appear in our dependency graph. We want to use 1.3.1 instead. So this means we'll have 1.3. If 1.3 is asked for and something else asks for 1.4, conflict resolution is going to end up using 1.4. It's not a forced version, but it's saying if 1.3 is the one that's going to end up being used, make sure we bump it up to 1.3.1. So it's replacing the requested dependency, and then we still do conflict resolution after we resolve that graph and get the newest versions, which is the default conflict resolution for Gradle. So that's a substituting module dependencies, effectively replacing what we can do in dependency resolve rules now. Very similar story for project dependencies. So we can now say substitute the util project with a particular version of a module dependency. So this is something you couldn't do before. So the only way you could do this before was to actually go in and find that project dependency and change it in your build script, or use some sort of custom DSL. And probably more interesting in a lot of ways is this is the substitution of a module external dependency with a project dependency. So this is the bit where we'll handle transitively. So let's say you've got project A depends on project B, downloads it from repositories, gets b.pom. B.pom says, okay, I need C and D and E. So then Gradle would just go, okay, go and get C, D, and E. You can actually say, replace that C with my local version of C. So let's say you're working on a project that ultimately depends on Commons logging, and you want to submit a patch for Commons logging because there's a bug in it. You can check out the Commons logging project right next to it, make sure it works with the Gradle build, add it in, and suddenly you'll be working against a local version of that without affecting any of the rest of the dependencies you've downloaded. That's kind of the killer feature of this, and I'm going to give some demos of that in a sec. And so finally, we have this sort of what we've shown so far in these previous two slides are the sort of the Fluent sort of nice to use syntax for these for rules. There are times when that doesn't meet your requirements. So in a lot of cases, you want to write a plugin that applies to a lot of different types of modules. You want to create a rule that inspects things and makes different decisions based on custom logic. In that case, we have a dependency resolve rule similar to a dependency substitution rule with a very similar syntax to dependency resolve rules that you're familiar with. So I'll just run through this because it's not necessarily clear. We've got a dependency substitution block the same way, and we're creating a single rule for this dependency substitution block. Now, the reason we use an all syntax here is because it's going to be consistent with our new model rules infrastructure. What we're saying is for every dependency that comes in, apply this rule. Okay, cool. So every dependency that's coming in, we're going to do some stuff. So first thing we're going to say is the requested dependency an instance of module component selector? So that's basically, if you've heard of module version selector, that's the old API I was referring to that sort of ties us into this idea of a group name version for every dependency. We now have a module component selector, we have a project component selector, we have a library component selector, and there will be more. So it basically allows this rule to be more flexible. So we say we only care about modules, and we only care about modules where the requested group is my.org. Cool. Okay, so what we're basically saying is every dependency comes in here. If it's a different group, we'll just ignore it. If it's my.org, cool, we're going to do this. We're going to say, on this dependency, use a different target. And we're saying use the group from the request, use the module from the request, but use this particular version. So we're basically saying, we're giving it a brand new dependency selector here, which is a module component selector defined in the same way that you define the syntax in your dependencies block. So when I do a live demo later, I'll show you how to do this with a project component selector instead of a module component selector. So does that make sense to anyone? Anyone have questions about this example? I'm happy to have. Yeah.
I have one quick question. If you have more than one kind of conflicting entry and substitute, which one wins? Like the last one ahead
Yeah, so the question is, if we have more than one rule and they conflict, which one wins? So there's two different things here. One is that this requested is the original request. It's not affected by any of the rules that happened before. And the rule that is last applied, so the rules are ordered, it's an ordered list of rules, and the last rule added is the one that will win. So multiple rules can make changes. They all get the original input as their input, and they can all use they can all make changes, and the result is the accumulation of all of those. You can also ask for the target of the dependency. So in the original, when the first rule is evaluated, the target and the request are the same. But when subsequent rules are evaluated, we have the original request, but we also have the new target, which is what will now be evaluated. So if you wanted to be sophisticated, you could actually say, I want to actually build a rule that's based on what I want to override the results of other rules.
But it still means if you use the substitute DSL,
yeah,
and the first entry is with this group and unaffected D use this version, then you have one which says for this group use this version, the second one will override the specific group, right?
Is that correct? So the second one will override your first, if you made the first one more specific. So the rules are there's no magic happening here. The rules are evaluated in order, and the result is the result of evaluating all of those rules in order.
Yes. I'm coming from Maven world, so if I have to understand the coordinates, it's group ID, artifact ID, and version, and from a Waggle convention, it's group, name, and version. So does that name translate to module over here?
That's correct. So the question is, what's the difference between module and name? And they are synonymous. It's just on the module component selector. On the module component selector, we refer to these as a group, a module, and a version.
Gotcha.
Okay, so I'm going to do a bit of a demo, show this stuff in action. So let's look over here. I might make it a tiny bit bigger. That's actually not the right one. That's the one we want. Okay, so what I've done here is I've created a multi-project build. We'll have a look at what's in here. So we've got a repository with A, B, and C published. We have a jar and an IB file for every one of those, and we have a single build.gradle file, which is defining the dependencies. So to start with, we've got a root project. You can kind of ignore the all projects block that was used. Basically, that allows each of the subprojects to resolve from that IB repository, and not much else. So if you look at this, the root project has a dependency on org.a. So say let's call it project A, and project A has a dependency on project B, on the external module B, and project B has a dependency on the project C. So if I run the dependency report for the top level project without any substitution rules, can anyone guess what I'm going to probably see? No one? Okay, so what I'm going to do is I'm going to run the dependencies report. It's much harder to type when you're standing up than when you're sitting down. Okay, so what I've got is I've got my root project. Root project depends on this external module, so that's being resolved from a repository. And then once you are resolving from a repository, all of those dependencies must be external dependencies, because there's no way for me to publish and have that published metadata say depend on a project. That never happens. So published metadata always depend on other published projects, never reach back into my project. So even though project B here says I depend on project C, when I publish project B, it's going to say I depend on the published version of project project C. That's just how publishing and resolution work. Okay, so what I could do is let's have a look at. If you guys aren't familiar with the dependencies report, let's have a look at what I could just change this to actually say I'm depending on project A instead of the external dependency A. Now you can see that my dependencies report says I depend on project A. Project A depends on the repository version of B, and repository version of B depends on repository version of C. So that's the graph I end up with. And then I guess if I change this one to project B, now we're going to get project A depends on project B, and because in my build definition project B depends on project C, we've got the full project part there, full of project dependencies there. So this is how you could do it manually, tweaking some dependencies and things like that. So what I want to do is show how we can do the same thing with dependency resolve rules. Dependency substitution rules. So I've just undone those changes. Let's just make sure that's all worked. Yep. So I've got the same. Everything. I'm using everything external. So now I'm going to try to adding a dependency substitution rule. So I'm going to say substitute module org A with project A. Let's have a look at that. You can see here that the substitution shows up. We're saying Gradle shows that org A was requested, project A was used in place of it, but all B and C are still being used because the project A is depending on org A. Sorry, on the project A is reaching out to the remote version of B. Let's try replacing B instead of replacing A. So let's say we want to actually work on project B, and we want to use a remote version of A. This time, we replaced B with the project version of B, and because of that, we are now getting project C, because that's what's defined in our build script. So it's just like if I changed in my build script to say use project B, except you can see clearly in the dependency report that it's being substituted. So we can do more things than that. We can sort of say, okay, actually I'm going to replace the project C with, I guess I don't want to do that, wouldn't make much sense, but that will probably work. Oh, thanks. Let's see what happens if I do that, shall we? So it gets a failed message. If I tried to actually build the thing, no. Oh, it's because everything's up to date, it doesn't do the check. Let's not worry about that. So with module, so never do anything in your demo that you haven't tried beforehand. Oh, see, threw me out completely. Okay, so now I'm actually substituting in a project dependent. So the actual, what my project is actually looking at is these things, is org A, which depends on org B. I'm replacing that with project B. Project B depends on project C, but I'm replacing that with the remote version of C. So basically you can see I can chop and change how I like with these things. And we can do more funky substitutions if we wanted to. We could say actually project, I don't know why you would do this, but you could say project A actually is a full replacement for project C. So we can say, cool, I'll just do that at the top of the screen again. So you can see that project C is being replaced with project A. The little star there, it actually says this is basically saying we've already included project A in the graph. It's a cyclic dependency, but Gradle handles those fine. So you can basically do the sort of substitutions that you want to do here.
Create phase if you have a certain dependency. Should it fail if you have a certain dependency?
So the question is, shouldn't Gradle fail if you have a circular dependency? Not necessarily. If you're not building things, so often our dependency graphs have circular dependencies inside them, but we resolve them all as external dependencies. So as long as we resolve them to a flat set of jars, so it's not actually a problem there. And it's possible to have true dependency cycles where you build the API of one dependency, and the API of one dependency is an input to an implementation of another, which is then the input of an implementation of the original API. It's hard to build things into that state, but Gradle doesn't need to fail if things were successfully built in that way. Gradle doesn't need to fail in that case.
Question, back to the IntelliJ right here. IntelliJ.
Yep.
So within the dependency substitution block,
Yep.
can I put the if condition that I only want to do the substitution when the B source code is available?
You can do. So the question is, can you add logic inside your dependency substitution block? While you probably can, what I would recommend in that case is to use a programmatic substitution rule, like I showed in the third example, which is you use a rule that applies the logic inside of the rule as opposed to outside of the rule. So you don't apply a logic to say which rules am I applying. You apply rules that encapsulate that logic. And I'm actually going to show that example of that coming up next. So generally, any conditional logic will be inside a rule block, which will look something like this. And then you can have ifs and all sorts of things in there to do that. So this is more, obviously this is Groovy code, and you can basically add whatever rule, you can add whatever logic is in there that you like. But it takes away some of the ability for Gradle to understand what's going on in your build. Whereas if you create a rule that does things, Gradle at least knows, here are the rules that I need to apply, as opposed to, I can't inspect this code and know which rules are going to be. So it's a subtle distinction, but I would recommend using a programmatic rule as opposed to logic within your build script. And I will show an example of that in a second.
Right now you're just replacing the dependencies in the root project. But if you go and build project B, the substitution rules won't apply.
That's cool. Yeah, so the question is,
how do you make it, for example, for all the projects and all the configurations the same substitution rule?
Okay, so the question is, in this case, I'm applying the substitution rules that only apply to the root project. And how would you make substitution rules that would apply to all projects? It's the same as applying any sort of configuration injection. Right? I want all of my sub-project builds to have this logic. You move the logic into, say, an all projects block. And then an all projects block, assuming that they all, so we have a couple of things we can do. We're only doing compile configuration here, so we could do configurations to all and then have resolution strategy and so that's for reconfiguration, and then we can move that up into the all projects block, and that will apply to all sub-projects as well. So just for my example, so the resolution strategy is tied to a particular configuration. So what you're doing in these cases is you're saying, apply the same resolution strategy to all of these configurations.
Question, what about the detached configurations?
The detached configurations, so detached configurations are still a problem. This is something we want to, they're a problem in a number of cases, and this is another one of them, in that it's not possible to change the caching behavior of detached configurations. It's not possible to apply rules to detached configurations. And I'm trying to think of what our current plan is to solve that. Our preferred thing is to move into the new software model and not have configurations at all. That we're also looking at what we'll probably be moving on to. Actually, yeah, there was something in the spec, in the design spec. A block that isn't tied to configuration. So we already have this a dependencies block where you can say components and apply component metadata to all. I think that's the syntax. It's effectively, what we want to do is come up with a way to apply rules that are global, cross-cutting, and they'll apply to all configurations regardless of how they're configured. We can't change the what configurations .all includes because that would be breaking the change. But we might find a new syntax for saying configure, like a new syntax for applying rules to all configurations, including detached.
Very often, you publish a version
Yeah, so the question is about, so I'm repeating the question for the video. So the question is about if once I discover that there's something wrong, I should be able to tell people, hey, by the way, my version's incompatible, version 1.3 is incompatible, use 1.3.1 instead. Right now, it's the onus is all on the consumer to make this work. So the consumer goes, right, I want to use 1.3.1. But there are people that it's already possible, and people do this already, publish a database of blacklisted versions and automatically generate their dependency substitution rules based on that database. So there's no public mechanism, and I think that my feeling is that Gradle.com will take us in this way. So what Hans was talking about today, where your build can connect to a remote service, it's really easy for us to then update Gradle.com and say, hey, by the way, you should let this build know that 1.3 is deprecated. So you can tell people they're using a deprecated version of something. Because that's always a problem when you don't know up front what's deprecated. But people do this already by having a central service within an organization that says always use these versions, and then the rules are based on that, the output of that service. So I better move on here. So, okay, so that was the demo of a pretty simple project substitution. So I want to quickly talk about the way we implemented this and the problem that isn't immediately apparent when we started. Wasn't immediately apparent when we started implementing this anyway. And it turned out to be quite a challenge to solve. If we just replace external dependencies with other external dependencies, it's not that big a deal. We just download them when we need them. It's all fine. Projects are a little bit different to that. So if you add a project dependency, there's a cascading series of causes that end up creating a bit of a headache. First thing is that when you add a project dependency to your dependencies graph, that implies that you need the project dependency to be built. And to build the project dependency, you need to execute the tasks to build that project dependency, right? So for external dependencies, we don't build anything. There's no tasks involved. You just download. The task graph is immutable once we start executing. So what we do in Gradle is we have this phase where we go, okay, let's work out all the tasks that need to be executed, and then we say, okay, cool, that's locked. Now let's start executing tasks one at a time. Those two things can work fine together, except once we say tasks can actually change what the dependencies are, which is quite feasible. So a task can currently go in, give me a configuration, check if it's empty. If it is, add some defaults. They do those sort of things. Suddenly we then no longer know what project dependencies are going to be applied. Because dependency, so this effectively means that we need to resolve, and because a dependency substitution rule is one of the things that can change the set of dependencies. So a task can resolve the configuration, which effectively runs these rules that adds a project dependency. It means we have to resolve the configuration before we build the task graph. But this is a change in behavior in Gradle. So what Gradle does now is we get to a task, we go, oh cool, it uses this, it has a configuration compile as input. We'll resolve it at that point, just before we execute that task, or actually before we work out if that task is up to date. That's part of working out whether we are going to run that task. It's still in the graph, we're just not sure if we're going to do any work. But in order to handle substituted dependencies, we need to have done that resolution before we even build the graph, because we need to be able to add new tasks into the graph. So that's kind of so basically a change. So that was one of the reasons we couldn't simply add project dependencies and have them go. What would happen if we just let you substitute in projects and didn't do any extra work? You would have been able to resolve that dependency the dependencies report would have looked fine, and you would have said, okay, grab me the jar now, and it wouldn't have been there because you haven't built that project yet. So, and this is actually a problem even without substitution rules. If you're in a task and add a project dependency to a configuration, so if you actually manipulate a configuration within a task and add a project dependency, that project dependency, while it will be in the resolution graph, will never be in the task graph. You'll never get those tasks built. So the problem exists. It's just that dependency substitution makes it much more likely that people are going to encounter this problem, because we're providing a clear mechanism of how to add project dependencies dynamically, and that that can only work if we resolve the configurations before starting to execute tasks. So yeah, this is the basically the working solution to this problem. We basically said there's a new opt-in, let's call it a mode for lack of a better word, for configuration resolution. So if you add any dependency substitution rules, if you use dependency substitution rules, you will be opting into this new mode of resolution. And what happens is we resolve configurations early. Any configuration that could impact the task graph is resolved when we build the task graph. So the configurations become inputs to the task graph itself. And we resolve inputs before we use them. In order to make it sort of keep working with most build scripts, we then will go, okay, if you change the configuration during task execution, we'll detect that. We'll go, okay, right, we've already resolved that configuration. We'll detect it. It's deprecated, so you'll get a warning to say you shouldn't really be changing your configurations after they're resolved, but we will re-resolve that configuration later. So this doesn't solve the problem of if you've added a project dependency in your task, that it will add to the task graph, but it just means you're more likely just being adding the most common use case is, I just wanted to supply some defaults. Did the user configure a version of check style? No, okay, I'll add the default version. So there are lots of tasks that do that sort of work. And we actually have added a new hook to configuration to make that easy. But just in case you build to doing that, we're going to warn you, we're going to say, hey, by the way, we had to resolve this graph twice. You probably don't want to do that. Try change, either use this new default dependencies hook for configuration, or find another way to do this. But we will continue to work. There's a use case that we can't solve with this. And that's basically if you have a task that publishes to something, and then another task that resolves that published module. So this was the killer that meant we couldn't just turn this on. Is that basically if I have task A publishes module, task B consumes that module. If we resolved before we ran task A, then it's going to be missing. So we used to resolve just before project B. So task B. Anyway, I've got a demo of. I've got another bit more time. Cool. I've got a demo of the multi-project builds showing some of this task stuff. So I'll get this going now. So this is very similar. This is a very similar project structure to what we had before, except that the sub-project builds are in. So each of those dependencies that you are in sub-project builds. So B declares its own dependencies, and we have a settings.gradle that's completely commented out. So we don't have. Effectively, we're saying, pretend these sub-projects don't exist. So Gradle won't even see these things right now. So I've got a build file here, and it just says, all my build file says is I depend on a remote version of A. So we should be able to. So if we look at the configuration. Familiar with this now. This is all what we saw before. But I want to work on how we can use this to use this functionality to build a real flexible multi-project build. So one that actually detects changes to things. So first thing I'm going to do is I'm going to use one of the programmatic style rules as opposed to a simple one. And I'm going to do. We saw this before. If the requested is a module component selector. And I probably only care if the group is org, even though it'll always be org for now. So let's just put a print in here. Shooting dot requested. What have I missed there? So if I have a look at what I've done now. So it's basically saying I found all of these dependencies. I'm not substituting them yet, but that's just showing the rules for every single one of those dependencies, wherever they appear in the graph. Well, so now what we're going to do is we're going to go, I'm going to try to find a project for that with the same name as that dependency. So we're going to say subproject equals, so Gradle has a find project method. It's on project. Projects always have a colon at the start, and then we're going to say def.requested.module. And I'm going to say and thank you. Let's have a look. It shouldn't find. It also should say null for all of those because we don't actually have a project for any of those modules right now. So cool. So we've actually found. If I now what I could do is I could actually go into settings.gradle, uncomment one of these. So now B is actually a part of my multi-project build. So effectively, I could delete A and C now, the directories, but I couldn't delete B. It's fundamentally part of what I'm working on. And you'll see I should be substituting the remote version of the external version of B with the project version of B. I haven't actually done the work of doing that. I've just said I'm going to. So let's do the actual work now. So if we go if subproject work isn't null, then I'm going to do. It's a use target is the method, and I can just say I want to target that project. I might put this into here because that's actually true then. And let's try that. So you can see now I've basically we've got a fully fluid multi-project build there. I can comment. I'm using commenting out of the settings.gradle file as a sort of a substitute for something more powerful where we can look in the directory structure and compose a settings.gradle file based on what's actually there. So this settings.gradle file is a GRUB script. We can add logic to that to look at what's actually there and make decisions at that time. So now I've just said I want A and C and I don't have B. And see the substitutions are working as we expect. So yeah, we've got 5 minutes, and then just. I was thinking I might have time to actually implement a settings.gradle file. Like you can imagine what it would do. It would go look. We have a project naming structure. Look for a directory named A. Here's my candidates. Look, iterate through, find any other candidates that exist, and include those in this project. So it's not rocket science to work out how to do this. This is a very basic example, but you can see with dependency substitution rules, it's possible to build a really sophisticated solution on top of this. So so I guess the answer to fluid multi-project builds now is a settings.gradle file, a custom settings.gradle file, and dependency substitution. There's lots of potential things we can do. Laurent hinted at some of them, which is basically trying to get rid of this concept of a fixed settings.gradle file, making the concept of substitution of dependencies a core concept of Gradle. So making projects and external dependencies more transparent to the consumer. So it's more about where do we resolve something from than what do we ask for. So that's the future. But this is a good stepping stone. It helps us build what we need to build without having to make too many deep fundamental changes. So I might get Laurent to come back up and we can answer any more questions. We've got about 5 minutes before lunch. Sure.
Does it handle latest version, the substitution? Can you substitute a project with the latest of some modules?
Okay, so the question is, can we use latest.version or it'll be latest.integration,
Yeah.
I think you're talking about,
Yeah, something like
in the syntax. So the syntax is actually a match on the selector itself. So if you wanted to replace Are you saying you wanted to replace with the latest dot?
Yeah, let's say I have project A depends on project B, and I just want to substitute project B with whatever the latest B that's published already.
Yeah, so what you would do to use the latest B would be to use either org::b:+ which is a synonym for org::b::latest.integration. Both of those will say get me the latest version of B, whatever it is.
Yeah, so the problem that we find using plus is that the pom.xml also use plus, it doesn't hint to the actual version.
Okay, but that's a publishing problem. That's not to do with the substitution rule. So substitution rules will not affect the published result of what you're putting out. They're only involved in how do I resolve this configuration, not about how do I publish this configuration.
Is this compatible then, with like the build ship Eclipse, how they build the class path container?
Sorry, I should have mentioned that. Yes, the new dependency substitution rules are fully integrated into the IDE plugins. So when we generate a build ship uses Gradle to tell it what the class path is, and the class path generation in Gradle is integrated with this. Yeah. I guess lunch is coming soon. One more question, sure.
So if you resolve the configurations, if it starts to be simple, like clean, the clean actually resolve those before it actually is really clean, therefore increasing configuration now?
No. So what Gradle will do is it will look at the tasks that are going to be added to the graph. And any input to those tasks, any configuration that is input to one of those tasks will be resolved in order to work out if we have to add more tasks to the graph. So clean doesn't have any inputs to it doesn't have any configuration inputs. So if you run clean, it won't resolve anything. But if you run compile, say Java compile, and it takes or say test, and it takes you end up with the Java, the compilation class path as well as the test compile class path configurations. Both of those have to be resolved when we build the task graph. So we won't resolve more configurations than we did before. We just resolve them earlier than we did before. Sure.
Because you mentioned fully logical studies of Gradle as an alternative, I've never done that before. What can you actually use at the point of time that Gradle evaluates settings of Gradle? What kind of information can you use there?
You've done lots of that stuff before.
There's pretty little information there, I think. So you cannot have the project objects that you can use, for example, when you're writing coding build at Gradle. So it's a little limited, but you can use any kind of Groovy stuff. So you can look at the folder structure and figure out.
Is it, for example, an easy way to find out what? Of course, the task hasn't been resolved yet. That it's actually going to be executed. But is there an easy way to query which task was requested?
There are no tasks at that point. So projects are not evaluated at that
Yeah, well, you're right, but I just want to get the command line parameter. If someone type Gradle build, I want to query that somehow.
I think you have start parameter and create, so you should have.
Yeah, I'm not sure if you can use that in settings Gradle.
So
I haven't tried that.
There are different objects that are available. The project object is not available at that time, but I think there's a settings instance that we have access to at that time, and I think the Gradle instance is available in the settings.gradle file as well.
Then
So,
you can do it.
and there's a start, and so you can inspect the command line for what was requested, but you can't inspect Gradle's interpretation of that command line. Does that make sense? So you can say what start parameters were given to Gradle at this time, but you can't ask Gradle.
And then you have to filter out what the task actually was on the command line.
That's correct, yes. Okay, last
So
question.
when you're resolving the dependencies from settings.gradle, when it looks for, when you define org.k and it doesn't find it locally, ideally it should go to the repository manager and resolve it. But if it's able to know that it's one of my sub-projects, why don't it go build it and then update that in its local cache and then reuse that for the next one? It's kind of the analogy that comes with the Maven parent com, and you have modules, so you have to use individual modules. So you find it in your local repo, you don't have it, then you resolve it from the remote repo. And even if it's not there, you build it locally and put it in your local M2 cache and then resolve it from there. Is this kind of a replacement for that?
Yeah, I don't quite understand how you would build it locally if you don't have you're saying you looked for it locally. Are you looking first looking remotely for something?
Yeah, first you look local. So
Right.
if I want, in settings of Gradle, I have A, B, C.
Yeah.
Right? I look for A, it says org.a, and if I look for org.a locally, I don't have it, right? I go, and if I don't have it, first I look remote, right?
Right.
I don't have it. I look local, I don't have it. So if it's there in my file system, I'll just build it and
Yeah,
keep it locally.
Sorry, yeah. So that Gradle does do that.
Okay.
Now, so I think there's it's a
So default caching takes care of this already now.
Yes,
So
I think so.
Okay.
if we decide that, hey, this needs to be built from local sources,
Right.
then we select those tasks that need to run to build your artifact locally. And then we check that whether or not we need to run those tasks at all, because, well, if it has ran before without
Right.
modifications in the input, then we can just reuse the one from the cache.
Right.
So that works automatically.
Okay. So do I have to, that's a part of the default resolution strategy?
This default task execution strategy.
Okay.